In this video, we are going to talk about total energy of a moving liquid. First, let us understand what are the different types of energies a moving liquid possesses. If you imagine a particular volume of liquid which is in motion, for example, if I open the outlet here, the liquid starts flowing out. When the liquid starts flowing out, you will see a particular volume of liquid is in motion in that tube. Let me assume that and find the different kinds of energies it has. So if you look at this portion of the liquid, I'll assume its mass as a delta M. Delta M is in motion, so it must have kinetic energy. We know that objects possess kinetic energy when they are in motion. This delta M amount of liquid is in motion, so it should have kinetic energy. If the liquid is coming out through the pipe with a velocity v, then the kinetic energy value can be written as Ke is equal to half delta M v square. This is very well known thing. Kinetic energy per unit volume, if you find kinetic energy per unit volume, that is half delta M by delta v square. We know that this delta M by delta v is nothing but mass by volume, can be written as half rho v square, where rho is the density of the liquid. So kinetic energy per unit volume of the liquid which is in motion is half rho v square. It depends on density of the material, density of the liquid, and velocity of the liquid. Then look at this delta M amount of the liquid. It is at a height h from the surface of the earth, or else from the datum. From the datum it is at a height h. So due to its height with respect to ground, it should possess gravitational potential energy. We know that gravitational potential energy can be written as mgh. Here the mass of the liquid is delta M, so it is delta mgh, where h is the height of the liquid delta M from the ground. Then potential energy per unit volume can be written as delta M by delta V into GH, which can be written as rho GH. So potential energy per unit volume of the liquid which is at a certain height h is rho GH. It depends on density of the liquid and height of the liquid from the surface of the earth. So these are the two types of energy which the liquid has. And there is another type of energy which liquid possesses because of its pressure. Look at this point. At this point, liquid has certain amount of pressure. Due to this pressure, it possesses energy. This energy is called as pressure energy. How can we say that liquid has energy at that point? For example, there is a nozzle, there is a lid placed at the opening of this outlet. If the lid is loosely connected there, because of the pressure of the liquid, the lid will be pushed out and thrown at a certain distance. So this is a work done by the liquid due to its pressure. So this is the proof to say that liquids possess energy, pressure energy, due to the pressure at a particular point. If you want, you just try to hold here with your hand, try to stop the flow of liquid from the outlet pipe with the help of your hand, with the help of your palm. you will experience the force on your palm, which says that it is exerting some force because of its pressure energy. So to find out the value of pressure energy I denote it as a PRE, pressure energy. This pressure energy is nothing but work done against pressure. So the work done against pressure is stored as pressure energy. So what I do now, to press this liquid inside, I have to work against the pressure. Look at this. On this opening of the outlet, how much pressure is acting? For example, if I assume the pressure as P and area of the outlet as A, then the force acting on the outlet is PA. Then to push the liquid inside against the pressure, I have to exert a force PA, which is equal to that of the force exerted by the pressure. And if I move this liquid into the vessel by a distance delta x, then the work done is nothing but force into displacement. Here force is pressure into area into the displacement is a delta x. Area into delta x is nothing but delta V, which is the volume of the liquid which is pushed inside. Then pressure energy can be written as P into delta V, and pressure energy per unit volume is nothing but P. So this is the third kind of energy which the liquid possesses. The total energy per unit volume, total energy per unit volume, the total energy per unit volume can be written as sum of the kinetic energy, potential energy and pressure energy, which is equal to half rho v square plus rho gh plus P. Here we know that this P pressure is nothing but static pressure, which is at a depth h dash from the surface of the liquid. So this can be written as h dash rho g. Wherever you want to replace h dash rho g with the help of P, you can do that because it is simply equal to static pressure. So this is the total energy per unit volume possessed by a liquid when it is in motion. And due to its motion it possesses kinetic energy, due to its elevation it possesses potential energy, due to the point where you are finding the energy, due to its depth from surface it possesses pressure energy. We can do one more thing here. If you divide the total energy with rho g, then the total energy becomes v square by 2g here, plus here rho g cancels, I left with h here, and if I take P as h dash rho g, then if I divide it by rho g, that also get cancelled. Then the total energy per rho g can be given by v square by 2g plus h dash. Here this is called as velocity head. This term is called as velocity head, and this term is called as elevation head, because h is nothing but its elevation from the ground, and h dash is called as pressure head because due to this much depth of the liquid, it acquired the pressure, it possesses the pressure energy, so that is called as a pressure head. But simply the total energy can be written like this. This is the total energy of the liquid. Thank you very much.